Today we'll be discussing scalar and vector quantities. Under this topic, we'll know the examples of scalars and vectors, resultant of vectors, how to determine resultant of vectors, resolution of an inclined vector, and of course, triangle of forces. Having done this, we'll take examples and you'll be given some questions to assess your knowledge of the topic we handle at the end of the day. Scalar and vector quantities. A scalar quantity is a physical quantity that has only size or magnitude. It has no direction. Examples are mass, speed, work, among others. While a vector quantity is a physical quantity that has both size and direction. Examples of vectors are velocity, acceleration, force, impulse, etc. Resultant vector. The resultant of vectors is a single vector that can be used to represent the vectors both in size or magnitude and direction. The resultant of vectors along a line is the sum of the vectors if they are in the same direction. The resultant of vectors along a line but in opposite directions is the difference in their magnitudes, and its direction is the direction of the bigger vector. Parallelogram law of vectors. The law states that if two adjacent sides of a parallelogram are used to represent two vectors, then the resultant of the vectors is represented both in size and direction by the diagonal of the parallelogram drawn from the common point of the vectors. This law is used to find the resultant of inclined vectors. Resolution of a vector. This is the splitting of an inclined vector into its vertical and horizontal components. Consider a vector f inclined at angle theta to the horizontal as shown below. This vector f inclined at angle theta. By the time we complete the right angle triangle, the vertical component of the force is f sub y, and this will give us f times sine theta. The horizontal component of the force is f subscript x, and this is equal to f cos theta. Triangle of forces. The law of triangle of forces states that if a body is in equilibrium under the action of three forces, then the forces can be represented by the three sides of a triangle taken in order. Example 1. Which of the following consists entirely of vector quantities? The options are A. Tension, magnetic flux, and mass. B. Displacement, impulse, and power. C. Work, pressure, and moments. D. Velocity, magnetic flux, and reaction. Answer. The correct option is D. Option A is wrong because mass is a scalar quantity. Option B is equally wrong because power is a scalar quantity. And option C is wrong because work is also a scalar quantity. Example 2. Two forces whose resultant is 100 Newton are at right angle to each other. If one of them makes an angle of 30 degrees with the resultant, determine its magnitude. Solution. Let the forces be F1 and F2. So since they meet at angle 90 degrees to each other, the resultant force F is 100 newtons and it makes angle 30 degrees with F2. Then we can use knowledge of resolution of vectors to get the value of F2. F2 makes 30 degrees with the resultant force F. Therefore, F2 equals to F cos theta, which means F2 equals 100 times cos 30. F2 equal to 100 times 0.8660. F2 will be equal to 86.6 Newton. Option C is therefore the correct answer. Example 3. Two horizontal forces, 10 Newton and 8 Newton are, and another force F, inclined at 30 degrees to the vertical, acting as shown in the diagram below, keep a body P in equilibrium. The weight of P is dash. The diagram is as shown. Solution. Resolving horizontally at equilibrium, 10 equal to 8 plus F cos 60. 10 equal to 8 plus 0.5 F because cos 60 is 0.5. Then 2 equals to 0.5 F. Therefore, F equal to 2 divided by 0.5, which is 4 Newton. Then also resolving vertically, weight equal to F sine 60. Weight equals to already F is 4 sine 60. Weight equals to 4 times sine 60 is root 3 over 2. Therefore, the weight of the body is 2 square root of 3 Newton. The options are A, 2 root 3 Newton, B, 2 root 3 over 2 Newton, C, 3 root 3 Newton, and D, 4 root 3 divided by 3 Newton. The correct option is A. Example 4. The value of force F in the figure above when in equilibrium is dash. The options are A, 10 Newton, B, 12 Newton, C, 20 Newton, and D, 27 Newton. The solution is as follows. Using the law of triangle of forces, then we'll be able to come up with this triangle. From this triangle, we divide 10 by f. That's dividing the opposite side by the hypotenuse. That will give us the sine of angle 30 degrees. 10 over f will now give us sine 30 is 0.5. That means the force F is equal to 10 divided by 0.5. The force F is 20 Newton. Option C is therefore the correct answer.